Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll review what we learned in week 3. So we only went through prime factor trees and then using them to calculate highest common factor and lowest common multiple. So if I want to calculate highest common factor of 36 and 48, I'm going to start by drawing prime factor trees for 36 and also 48. So for a prime factor tree, the goal is I want to take a number and write it as a whole heap of prime numbers multiplied together. So to do this, I'm just going to factorize 36. I'm just going to find any two factors of 36. So I'll start with 6 and 6. It doesn't matter which factors you started with. I could have done 12 and 3, 18 and 2. I'll end up getting the same answer in the end. So 6 and 6. What I need to say is 6 prime. Well, no, it's not. So I need to factorize 6. I'm going to factorize it as 2 times 3. Is 6 prime? Well, no, I just said it's not. It's 2 times 3. So now what I have down the bottom are just prime numbers. 2 is a prime number and so is 3. So what I have done is I've written 36 as 2 times 3 times 2 times 3. A whole bunch of prime numbers multiplied together. So 2 times 3 times 2 times 3 in index form, there are two 2's. 2 is being multiplied by itself twice, and 3 is being multiplied by itself twice. So this is the prime factorization of 36 in index form. Let's do something similar for 48. So we'll find two of its factors. Any two will do. I'll do 12 and 4. So 12 is not prime, so I factorize it to 4 times 3. 4 is not prime, I factorize it to 2 times 2. So down here, I'm not quite done. 2 and 3 are prime, but 4 is not. So I have to factorize 4. I keep factorizing the numbers until I'm left with just prime numbers. Here I have 2, 2, 3, 2, 2, all prime numbers. So that means that 48 is equal to, now there are 4 2's being multiplied together. 2 times 2 times 2 times 2 is 2 to the power of 4, and there's also a 3. So it's 2 to the power of 4 times 3. That is the prime factorization in index form of the number 48. So how can I use these to find the highest common factor and the lowest common multiple? What we did was we learned drawing a Venn diagram. So a Venn diagram has a rectangle and inside are two circles that overlap. So I'm going to write the numbers 36 and 48. What I'm going to do is I'm going to write all of the prime factors. So in the middle, I write what is common, what both of them have. Well, both of these have two 2's and a 3. So I'm going to put two 2's and a 3 in the middle. That's what's common. Now what goes over here is what 36 has that 48 doesn't. Well, 36 has two 2's and two 3's. So I've got the two 2's and one 3. I need another 3 so that all of the numbers in this circle here multiply to 36. So similarly for 48, I've got 2, 2, and 3, but I need 2 more 2's. So now all of the numbers in the 48 circle multiply to 48. So how is this useful? How does this help us find highest common factor and lowest common multiple? So the highest common factor is just the things in the middle of the circles multiplied together. So the highest common factor of 36 and 48 is just 2 times 2 times 3. 4 times 3, which is 12. That is the highest common factor of these two numbers. So for the lowest common multiple, I multiply all of the numbers in both circles. So I go 3 times 3 is 9, times 2 is 18, times 2 is 36, times 2 is 72, times 2 is 144. The lowest common multiple of 36 and 48 is 144. And that's actually quite a bit easier than writing out all the multiples of 36 and, the first few multiples of 48. So another way you can find the lowest common multiple, it's also the two numbers multiplied together divided by the highest common factor, which was 12. Now, 36 times 48 might take a while without a calculator. So what you can do is cancel. You can just go 36 divided by 12 is 3. So the lowest common multiple is 3 times 48, which is also 144. Either way you want to find the lowest common multiple, I don't mind. You can get it from this Venn diagram, or just to find the lowest common multiple of two numbers, you can multiply them together and divide by their highest common factor. So prime factor trees can also be useful for finding square and cube roots. So for 36, I found that it's 2 squared times 3 squared. So that, of course, means that the square root of 36, well, I can just square root this. It will just be 1, 2 times 1, 3, which is 6. Square root of 2 squared is just 2. Square root of 3 squared is just 3. Can help me with square roots as well. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.